Okay. If you would, since you're good at it, would you make sure that when we begin our delta math, if you think to tell me to turn this off so I don't do the exact same thing again, that'd be great. And now y'all get to hear that on video if you go back. Okay, so let's go over this. Y'all, yesterday we did the tables and trying to determine if they're linear, quadratic, or exponential. So I just, again, trying to spiral back and look at it one more time, okay? So, y'all, a lot of these are visual. They're not as hard as delta math. You can actually look at this and tell what the pattern is. What is the pattern here? We are adding 4. When we are adding and subtracting, what kind of function is that? That's linear. Boom. Okay, if you did the math and did 9 minus 5 and 13 minus 9 and 17 minus 13, you got 4. So it's linear. Okay, this one, y'all, this is the hard one, but visually take a look at it. It starts at 0, it goes down, and then what happens? What do we know that visually goes down and then back up? A quadratic. But mathematically, I'll show you how it works. To get from here to here, we subtract 1. From here to here, we add 1. Here to here, we add 3. Here to here, we add 5. If this was all the same, it would be linear. But we're going to take a second difference. Well, from here to here, I add 2. From here to here, I add 2. And from here to here, I add 2. The second difference is a quadratic. Here, what's my pattern? Multiply by 3, and probably if you said divide, you actually checked it with division, and when you checked it with division, you did 9 divided by 3, 27 divided by 9. But here's the deal, what kept showing up on your calculator? That right there, that's you're multiplying by 3. So great. So that's exponential. How'd y'all do on that? Great. Okay, y'all, I just wanted to grab up some things here to see if you knew, and come to find out, this little delta math we're going to do today, it is going to have x and y intercepts on it as well. So y'all, you might want to pay close attention. We got to be able to find x and y intercepts from a table. So when y is 0, these are your x intercepts. So negative 2 and 2. If we wrote them as ordered pairs, it would be negative 2 comma 0, and it would be 2 comma 0. These are my x-intercepts, y'all. You're going to have to know that from your table. Okay? Also today, you're going to need to know, how do I find my y-intercept? It's where x is 0. X is 0, that's my y-intercept. How do I write it as an ordered pair? It'd be the ordered pair 0, 4. Now let's look at my pattern. 0 to 3, 3 to 4. 4 to 3 turns back around, and 3 to 0, quadratic. If you did the second difference, it should have all been the same numbers. Okay? All right, here, x-intercept is where y is 0. And if you had to write it, it would be 3 comma 0. The y-intercept is where x is 0. And by the way, y'all, this is in the notes. This should not be new material to you. This is in our notes. And then let's look at our pattern. 12 to 9, 9 to 6, 6 to 3. What are we doing? Subtracting. What kind of function is that? Boom. Y'all okay? And then out of the blue, I just threw in an oldie but a goodie. This is asking you where the y greater than 0 means positive. It's asking you where are the y values positive, where is the function positive. Well, for that, it's above the x-axis, so you got to locate the x-axis. That's right there. And the part of the graph that's above the x-axis is right here. Now, where is the breaking point at? It's right here. What is that? What is that x value? It's 2. Now, y'all, if I put an imaginary line here, it's easy to see. Is this line on the left or the right side of 2? It's on the left. Well, on the left is where x would be less than 2. So the answer is D. Maybe I better say that again. If this is your 2, remember, the left side is where it's less than 2, the right side's where it's greater than 2, and I need to know where is this part of the function at. Well, it's on the right side of 2. It's on the left side of 2. So that would be my answer. The x values are smaller than 2 here. Okay? All right, y'all good? Yeah? Okay. Okay, we're recording again. All right, so y'all, basically what we've got is I'm going to just try to find another way to explain domain and range to you. The only way to do it is just to give it to you. So, kind of boring, but here we go. The first thing I want to do is I want us to ignore all these curves for right now, and I just want to take a look at some stuff on a number line, okay? If I, let's say, pick a number, let's say -2, and I want to represent all the numbers on the right side of -2, I would, you probably remember from 7th or 8th grade, we're going to shade this area. And in 7th and 8th grade, you had to write an inequality for that. And it would be x is greater than or equal to -2. So I'm hoping you remember this from like 7th or 8th grade. If I want to represent all the values bigger than -2, that's this way, and include -2. Do y'all remember this? Maybe even from me. Okay? That represents these x values. Okay? Now I'm just going to do another set. I am going to represent the values where x is -2 and all the numbers smaller than -2. Well, last year and the year before, you had to write an inequality for this, and it is where x is less than or equal to -2. So this shaded area is representing all the numbers less than or equal to -2. This shaded area is representing all the numbers greater than or equal to -2. Now here's what I'm going to do. I'm going to put both of those on one graph. So I'm going to put -2 and all the numbers greater than -2. I'm going to put that here. And now I'm going to put this here. I'm going to represent those. And now what I want you to do is I want you to look at this number line and tell me about the numbers that I've shaded on this line. I've shaded all of them, right? Like all of them. All of them. Y'all, when every number on the number line is included, there's a mathematical way of saying that. It's all real numbers. There's a mathematical way of saying that. When all the numbers are included on a number line. Okay? So I just wanted you to kind of see that, because now I'm going to see if I can help you relate a domain. Okay? Okay. For domain here, I'm going to relate something we've already done. Okay? We have done increasing and decreasing intervals. Okay? So if we know that the increasing and the decreasing changes right at that vertex. Okay? Which is where x is -3. Okay? So if I'm riding in a roller coaster from the left, the first thing I do is go downhill. Y'all agree? So this is where it decreases. What we've had to do is we have had to name all the domain values where it's decreasing. Well, so what we did is we basically represented that -3 and everything on the left. Well, I'm going to graph that on this number line. That's everything to the left of -3 on the number line. That's where we've got decreasing. Okay. Now, if we had kept going, what happens over here? Okay, so that's where we're increasing. Well, we used our part of our domain values to answer where this is decreasing. It is on the right side of -3. So let's put that on this number line. See how these X values represent where it's increasing. This is called X is less than -3. This is all the numbers smaller than -3. This represents all the numbers that are bigger than -3. Now, y'all, this we've been doing over and over and over again. Identifying the part of the domain where it's decreasing, identifying the part of the domain where it's increasing. We've been doing this over and over. So, y'all, basically, the idea is the entire domain is both of these. The entire domain is everything. So it's going to be the decreasing and the increasing. Part of the domain was decreasing. The other part of the domain was increasing. If I want the whole domain, I put those together. So y'all, let's put them together. Okay? So we've got all the stuff bigger than -3. We've got all the domain values smaller than -3. Now let's have a little discussion. Does anybody know with decreasing and increasing, why do I not have an equal to bar? Why am I leaving that spot right there out? For increasing and decreasing, why am I leaving that point right there out? Lyric? Well, it's a curve, okay? It's the vertex, increasing and decreasing. Why am I not including that in these domains for decreasing and increasing? That's right. Y'all, the vertex, technically, it's not increasing or decreasing. Think about in a roller coaster. Okay? When you're in a roller coaster, when you get to the very bottom, there's a moment in time that you're not going down and you're not going up. A split second there. Y'all, that's why we can't say the vertex is decreasing and increasing. It's not. If you think about going uphill to the top, y'all, you're going uphill. You feel the pressure. You're going uphill. But y'all, there's a moment, just a moment, that you are not going uphill. You're not going downhill. You're about to go downhill, but you're not. Y'all, that's why the equal to bars are not included here. But here's the deal. Y'all, it exists there. It's there. The curve is there. So, y'all, I can go ahead and fill that in because it's there. It's right there. So now what I want to say is I've got the decreasing part and the increasing part all put on one curve. How do I say that right there? Look right here. So if I'm trying to say my X values are everything, then the answer is all real numbers. So the domain for this quadratic is all real numbers. I'm going to let y'all write it, and I'm going to try to say it one more time. Okay, the domain what are all the X values contained on this curve? Domain is the X values. Okay? What I was trying to use to explain to you is that when you have been doing decreasing, you have actually been giving me part of this domain. When you've had to find increasing, you have actually given me part of the domain up here. Well, y'all, if you take the parts and put them together, that gives you the entire domain for the function, which in this case is all real numbers. And by the way, if you have a generic quadratic like this, or even turned upside down, the domain is all real numbers. It's all real numbers. Okay? All right. Now, if you flip over, okay, now look what I've done here. Y'all, this is still a quadratic. Y'all, the domain has been restricted. Who knows what restricted means?
It stops at two certain points.
Restrictions are things you can't do, right? So y'all, the domain has been restricted. So in other words, this is what a quadratic really looks like. What it really looks like. But in this particular problem, they're like, no, we don't want any of this, and we don't want any of that. That's called a restriction. We've been restricted. Okay? So now let's take a look at the domain for this. Okay, first of all, I'm going to break it up again, because there's an increasing part to a quadratic and a decreasing part to a quadratic. So basically, here's my vertex. It's at 5. And because of the restriction, it starts at 0 for my x value. And because of the restriction, it ends at 14. The vertex is at 5. So increasing is where? It's this guy. Well, how do I write him? Well, he now starts where? At 0. He stops where? At 6. And he's everywhere in between. So I'm going to shade this. So this is the increasing part of that graph. Well, how do I write that? Well, x is between 0 and 6. Now again, I didn't put equal to bars. The reason why is right there in the beginning it's not increasing, and at the top it's not increasing, but we do know the points are there. They're there. Yeah, what's wrong?
Wait, why wouldn't that be 5?
Oh, it is 5. That's been a 5 the whole time. Y'all couldn't tell.
Wait.
What's the 5 on 6? No, it's 5.
It's 5. I got so excited I grabbed a 6. I should have grabbed the 5. Okay, so now there's another part to this graph, and it's the decreasing part. Okay, well, that goes from here to here. So let's put that one here. This time I'm going to grab the 5. 5, and then where does it stop?
14.
And it's everywhere in between, right? Well, this is the decreasing part. And if I wanted to represent that with the domain values, it would be x is between 5 and 14, right? Right. So here's, again, the point I'm trying to make. This curve has an increasing part and a decreasing. So the increasing part is these x values. The decreasing part is this x values. If I want the whole thing, all the x values, I put both of these on a graph. If I want all of my x values. So let's put them both on a graph. If I put this one on a graph, it's from here to here, and it's all of this stuff. If I put this one on the graph, it's from here to here, and all the stuff in the middle. So y'all, this is the entire domain for this function. There's an increasing part, there's a decreasing part. When I put them together, this is my entire domain. Well, how do I write it? Well, here's the, I love, y'all said all real numbers. Why is it not? Look right there.
Oh, it's restricted.
It stops, look right there. It stops. So see, it's not all real numbers, because if you said all real numbers, you're saying it's beyond 14, and on this side beyond 0. It's not. It's contained between 0 and 14. So 0 to 14, and by the way, to include, we need to include these points because they're there. They're there. They're just not a part of increasing or decreasing. Okay? So again, what am I trying to explain to y'all? I'm trying to explain what domain is. Domain are the x values found on this. Okay, what we've already done is we have actually listed the domain where it's increasing. What we've done for a few weeks, we've listed the domain where it's decreasing. And if I put them both together is how I get the whole domain. So let's go ahead and label this as the entire domain. It's the entire domain. That's where it's increasing. That's where it's decreasing. This is the entire domain. So hopefully. So that was quadratics. Let's look at linear. Okay? Y'all, with linear, I can't explain it with increasing and decreasing because with linear, it's either all increasing or all decreasing. So it's hard for me to explain it that way. So what I'm going to explain it with is positive and negative, greater than 0, less than 0. So there are two parts to this graph. There is one where the function is greater than 0. There's also a spot where the function is less than 0. So, and we know that positive function means above the x-axis, negative is below. So, above the x-axis is here. Let's graph those x values. Well, they're at 3, and they're to the left of 3. So, let's graph that. 3, and notice everything to the left of 3, and do you see it's going to go on forever? See the arrow? So it's everything to the left of 3. It's not restricted. It's going on forever over here. Okay? Well, how do I write that inequality? X is less than 3. And I'm not going to include that spot because that spot is not positive or negative right there. I'm not going to include it. Okay? Okay, now let's go to the negative part. Okay, well that's this guy. And notice he's got an arrow. He goes on forever. By the way, we can label him. This is where f of x is greater than 0, right there. That's the domain for that. Now, this part of the graph is at 3 and everything on the right side of 3. So let's graph that. Here's 3 and here's everything on the right side of 3. Well, how do I write that? X is greater than 3. And that is where the function is negative. So again, the whole idea I'm trying to get to is, for domain, is this part of the graph are these x values. This part of the graph are these x values. If I want all the x values, I put both of them on one number line. So let's put them both on one number line. I'm going to put this on the number line. I'm going to put this on the number line. And yes, I'm going to include the 3 now because it does exist. It's just not a part of being positive or negative, but it does exist. So what have I shaded here? I've shaded all of them. So what is my domain? It's all real numbers. Okay? So another thing to remember, y'all, if you're just given a linear, the domain's going to be all real numbers. If there's no restriction, it's going to be all real numbers. And again, how did I try to explain this to you? To show you different areas. This is where my domain is less than 3. This is where my domain is greater than 3. And when I put it together, I've got all the x values, all real numbers. Okay? Okay? Now, I want to restrict the domain again. Okay, so let's look at a restriction. Okay, so if you take a peek at this, y'all, it starts at 0 and ends where?
Or 24.
At 24. And what do I mean by restriction? No, you don't need to draw this, but y'all, here is a linear model. But they've restricted it by stopping it where x is 0. They've restricted it by stopping it where x is 24. So how do I represent that? Well, 0 to 24 and it's everywhere in between. So that's my full, that's the domain. Well, y'all, how do I write it? It's not all real numbers, because look, we don't want to include the numbers on the right side of 24 because there's no graph here. We don't want to include negative numbers because there's no graph over here. We just want to have these numbers. Well, it's an in-between statement. X is between what two numbers? 0 and 24. Y'all, that is your domain. That is your domain. And yes, I'm going to use equal to bars because it touches right there and it touches right there. So that is my domain. These are all the X values contained on that line. Remember, domain is the X values. Okay? All right? Exponential. Y'all, exponential, it's hard to break it up. The reason why is it's always increasing, so I can't break it up for you. So basically, if you just take a look at this line, look, it is literally going to continue to move to the left. Look. It is going to continue to move up and to the right. So y'all, I'm literally covering this entire number line. And it keeps going. And it keeps going. Now remember, we're talking about X values. If you're confused by saying, well, Miss Batchick, it's not under. Y'all, that's not X values. Those are what? Y values. Okay, but for the X values, look, it's going to keep going this way. And it's going to keep inching its way this way. All real numbers for your domain. Your domain is all real numbers. Okay? And so that I'm keeping things organized, I've restricted your domain here. Okay, y'all, this is a natural restriction. This is a graph of bacteria growth. Well, y'all, what is your domain being represented by in this graph? Time. Y'all think about that. Y'all, negative time doesn't make any sense. So if you'll notice, where do the X values start? At 0 time. So y'all, they start right there. But if you notice, even though there's no arrow, do you see how it goes to the edge of the graph? Y'all, it's going to keep on going. The time's going to keep on going, so check this out. If I had to shade this on a number line, well, how do I write this? I write X is greater than or equal to 0. So y'all, this is what the domain restriction looks like. Do you see what I'm saying? Okay. And y'all, again, just a generic exponential model, the domain is all real numbers. Okay? What's going on? Yeah, we're not done. I mean, you can go, but we're not done. I just saw both y'all at the same time. I'm trying to figure out what's up. I thought I was like, what's going on? Is it a fire drill? What's up? Is something on fire? What's up? Okay. You were stretching. You're going to restroom. That's fine. Sorry. I was like, they trying to tell me something. Okay. Okay. Y'all, this is not going to take long, but look. We're not going to do domain now. What are we going to do? Those aren't the X values. Those are the Y. Okay, so let me tell you what I did. Y'all, do you notice that I took a number line and now I made it vertical? Why would I do that? Because it's the Y, and y'all, the Y's are this vertical number line. When I'm trying to figure out my Y values, I don't look this way. I look this way. So I've made us some number lines. Okay, so let's check this out. The range. What are the Y values on this graph? Well, think about this. This is called a minimum. Well, what does a minimum mean? It means the lowest place on the graph. The minimum means the lowest place on the graph. Well, what is that? Negative 6. Let's put a dot on negative 6. Now, is my graph above it or below it? With arrows. So y'all, if I want to represent these values, I'm going to shade this way. And now, look how cool this is. Yeah, -6, and the graph is above it. Well, y'all, look how cool this is. Y'all, if I turn it sideways, it's still just a number line. How do I represent that? Greater than or equal to -6. And here's the thing. Should I put an X here?
No.
What should I put there? Because it's Y. It's the range. So, y'all, that's your range. Your range is all the Y values greater than -6 and equal to -6. Equal to because it actually touches. There's a point down there. Okay? See how that's how you do your range. Okay, let's do this range. Am I going too fast? Did y'all write that? Might want to do this. I would write range. I know it's written in the top corner of your paper, but that's your range. Okay? Okay, now let's take a look at this one. Y'all remember, range is this axis. Okay, well, where does it begin at? 0. Y'all, that's 0. And now notice, the graph is here. Where is the tip top of this thing? And you don't need to be extremely accurate. The tip top is what value? Around about 80.
80.
Okay? And y'all, the graph is everywhere in between, right? Look. It's everywhere in between. So y'all, I'm going to shade that to represent all my Y values. Y'all, this represents all my Y values. So how do I write it? Well, y'all, it'll help if you do this. If you turn your paper sideways, the range is in between 0 and 80. That's your range. So if you want to write range, it's there. And all I did was turn it sideways to look like a number line, but it's easy to tell that from here to there is where my graph is. What are the Y values from here to there? Well, from 0 to 80 is my Y values. Okay? All right? Linear. Well, y'all notice my graph's way down here with arrows. It goes way up here with arrows. What all's going to get shaded here? Everything. How do I say everything? All reals. So my range is all real numbers. And y'all, in general, there's some weird linear ones, but in general, if it's got a slant and it's just linear, the domain and the range is going to be all real numbers. Both of them. Yeah.
Can you show me what you put as this on?
Down here at the bottom. 0 to 80. Y'all hang on, the pain's almost over. Okay, all right. Okay, remember we're doing range now. Okay, so I've restricted it, obviously. Well, what is the lowest Y value? 0. What is the highest Y value?
6.
And the line is everywhere in between. So we would shade everywhere in between. See, these are my Y values. Now, how do I write that? Well, if you turn this sideways, it's easier to see. Y is in between 0 and 6. That is my range. Okay. right. And last one, we cannot forget an exponential when we're doing range. Okay, well, y'all remember this way and this way is all real numbers. But y'all range is up and down. So I want you to check this out. Do you remember this guy? He has a name. What is he? For an exponential, he's imaginary. He's called an asymptote. Somebody tell me about an asymptote. It's an imaginary borderline where the curve can go to it but never touch it or go over it. So y'all, this borderline here for this particular one is actually at y equals 0. This is your x-axis. It's where y is 0. So let's talk about range. Well, at 0, it never touches it, where y is 0. It's not under it. Where's your graph at? It's above it. And it goes on forever. So what do I highlight? I shade all of this. Why do I have an open circle on the 0? Because this really never touches 0. I know it visually looks like it, but it never touches 0. Okay, so now how do I write this? Well, if you turn it sideways, it looks like a number line. So how do I write that? Y is greater than 0. Y'all notice there's your asymptote, and that's the limit of your range. Asymptote, limit of your range. That's not a coincidence. If your asymptote is at y equals 0, your range is going to have to be above or below it. Like you could flip that over, but typically y'all's are on top. Okay? So that's your range. It's all the numbers greater than 0. The reason why there's no equal to bar is because it truly never touches this fence line. Okay? I bet you guys can now tell me what this range is. I bet y'all can tell me what that one is. This one is y is greater than 0. What's that range? Y is greater than 3. There is an imaginary borderline here at 3. I realize it looks like it touches it, but it doesn't. And the curve is above it. The curve is above it. It's never going to touch it. So that is the shaded area for your range. And it's y is greater than 3. Okay. So y'all, that's about all I got. Like, I don't know any other way to explain domain and range. I've explained it a couple ways. So just know domain and range is new for you guys. This is your introduction in Math 1, and we're just going to get through it. So let me tell you what we're going to do for the rest of today. What's wrong? Just listen. So your delta math today is comparing two functions, two of them. So y'all, this guy here, his name is f of x. This guy here, his name is g of x. Y'all, they're just using them so that you know the difference in the two things. These are two different functions, okay? You are going to have a comparison of maximum and minimum values, and then they're going to throw in some y-intercepts, okay? But let's talk about maximum and minimums, okay? First of all, y'all, visually this is easy. Does this graph have a maximum or a minimum? It's got a maximum. Why? Because it's got a top. Let me tell you one misconception from today. Y'all, what is the maximum here?
3.
It's 3. Y'all, it's not a maximum because 3 is positive. That has nothing to do with it being a maximum. You can have a maximum of -5 if I move this down. The reason why it's a maximum, y'all, is because there is the highest value is there. That's why it's called a maximum. It's not because the 3 is positive. It has nothing to do with that number being positive, okay? The highest point on that graph is 3, okay? So the way you're going to fill this out, notice it says for f of x is the max, because it's a maximum, you're going to have some that are minimums. the maximum value of f of x, okay, that's this guy, is 3. See that? Now, y'all, if I have a quadratic with a maximum, can there be a minimum? If you got a maximum, in the same graph, can you have a minimum? You can. You only got one maximum or one minimum. So, y'all, they're just trying to get you to realize there is no minimum. Now, if your graph has a minimum, there's not going to be a what? Not going to be a maximum. Okay? Now, they're going to do this again with the table. Y'all, they're going to do it again with the table. And y'all, people are struggling with the table. So I need for y'all to watch. The blank value, well, I'm just going to tell you, folks, you're either comparing two maximums or two minimums. It's not going to be a maximum and a minimum. So the fact that that has a maximum, I'm just going to tell you this. How do we locate it? Well, y'all take a look at these numbers. We start at -3, then we go up to 0, then we go up to 1, then what happens? Goes back down. So, y'all, if this is up, 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 and then down, y'all, right there is your maximum value. Notice it's the largest number in that line. Look, it's the largest number in the line. So that is going to be 1. And if there's a maximum, there is no minimum. And now, y'all, all they're trying to get you to do is compare these. This number is bigger than this number, right? So f of x is greater, has a greater, and we were dealing with maximums. Okay? Okay, now, y'all need to know something. I know where you're going to struggle, so if y'all away, y'all, they're going to change this to y-intercepts. Y'all, you've got to know where a y-intercept is. Y'all, here's your y-intercept. It's not here. Y'all, it's right there. Y'all, that's your y-intercept. So when it asks you for a y-intercept, you're wanting to find that part there. Okay, how about in a table when they ask you for the y-intercept? There's not one here. It's when x is 0. Y'all, you gotta be able to pick it out of the table. This right here is an x-intercept, y'all. But a y-intercept in a table is going to look like this. That's the y-intercept. People were having a hard time with that. That's a y-intercept. They're going to ask you to compare those two. Okay? The only other thing I can tell you they're getting mixed up on is this. And watch, I bet I can get y'all too. I want to know what the maximum value of this is. It's 0. Guess what everybody's answering? Y'all, 2's not a y value. 2's an x value. Y'all, the maximum value of this, it's at 0. So I'm just saying that was throwing people too. So you might want to write that down. Max value 0. Okay, y'all, last but not least, if you're doing a Delta Math that has these as your problems, don't put this in your notebook. Don't put it in your book bag. Leave this out. Now, find a friend. I know you're going to talk in chat. Let's just keep the noise level low and let's try to do this. Okay, let's try to practice. Folks, if you have someone at your table that wants a friend to come sit, just kindly move to another table. Okay, if you don't want to sit with anybody, just move to another table. Okay? I need to pull it up. So like that, Cheyenne. Like that, Cheyenne, like that.